This
So if you
conference
look at
will
this,
now be recorded.
yeah. So if you look at the dashboard, if you have enabled this, um, you know, APM, which we did yesterday, after generating some time, this is a basically different applications. Yesterday we had a different application chat. Let me show you, which I disable it. 2 days, if you go for that, you'll have a different applications like that. So like this, you'll have a multiple applications here. This one service, this is called service, okay, and here is another service. So here you get when you are last deployed. So this I deployed 4 hours ago. This one I deleted it because I needed that infrastructure. So now here you see the request, this many request which you have per second, and here you have 30.4 requests per second. And here you see left side, this is the type. Type means what kind of service that is, whether it's a web service, database service, cache service. Function means it can be Lambda. So Lambda, which you can find on the AWS serverless, and some custom also. Now, if you see that here, this you can see the list of service or service map also. Now, all the services will be here. Now, each request, I repeat, each request, you will see here traces. Let me show you traces here. Let's say these are the traces which I got it. So from last 15 minutes, I did not get it. I stopped the services. So let's say if you go for 4 hours, you'll have a many traces. You see here. Um, this is the traces, and here. Okay. So here, this is the date when that request has happened, which is the service name. What is the resources has been used, which URL basically. Here it is, duration, method, and status. So these are the things you will get it. All services, all the request. So all the request here traces all this. You can scroll down and see that. Now you can filter also by multiple filters are there. So if you see that left side, filter by status. So whether it's a 200 errors or okay. Errors means some 4x or 5x we will consider as error, and okay. So these are the things. Environments, prod or test environment, whatever it is you set through the APM. You can filter the traces by services also. You can filter the traces by the resources also here. So I had hardly few applications which I initiated through these other resources. And type, error type, and here these are the types of post, method 200, or what exactly get post, get post, delete, put. These are the method. Status code like 200, 3x, 4x, 5x. No. So these are the way you can each traces you can do that. Now if you see that here, here uh, this part. So here you have a graph which will help you to understand duration which was up actually. So 4 hours. So how many total requests you received? So here if you see that this is the total number of requests. This is for the 4 hours, last 4 hours. If you change the window, then again it will change. And here you see the request for every minutes or something like that. You can customize this one. How many total errors you got it? What is the latency here? This is here less, and stuff like that. And you can visualize using list. This is a list format here. This is the list, or you can use the time series also. So put it up time series and see here. You see that all the number of requests as per the time series and all. Okay. So this is also you can do that. Top list means total. What is the top list for the 202? Which you see that here we got it 202 request from last 4 hours, which has a you know highest request timeout or something like response timeout or something like that. So 200 indexed span from custom retention filter. So this is something which you have. So you can customize all this thing. You can put it in a table format also. Here you have a table format. You can also add more, let's say you can add environments. So that also you can do that. So here, okay. So this is something you can work with it. So come back to the services. Now here, go to 4 hours, go to services. Now we need to understand what exactly this is. So let's understand some of the options which is on top. So here again is durations. Now here you have a service summary. So this summary here is like a deployment. So when you add a code in application like a Tomcat, there you set the deployments. So for example, if you want to see that, how do you do that? This I was showing the demo, one more demo just before this session. So here you can see the deployment version 1. So here you'll have a version 1 and version 2. You can have it multiple things. How much total errors you got it here. SLO means service level objective, which you can set it up here under the monitoring here. And whatever you set it up, if it is violation, then you will see that for this particular service, what is SLO set. So you'll see that here. And for this particular service, if any incident you want to create one incident or work, then you can do that. So here, how do we create it? So click on this here, create a new incident, or go to some incident, configure the incident and stuff like that. Here you can also add a new latency SLO, add new availability SLO. You can add it here. So whatever for this particular service, you can see here. It will go down, and which is here. Now here, the moment you read it, you'll understand that what exactly this is. Requests an error, okay, and this is a average request, 365 requests per second. For this duration is 4 hours, which I set it up. Now, how many total errors you have and hits? So you can check this one off, and you can also do that. So you must be wondering that red is not visible because this is so small. You will have somewhere here. Okay, so I just drag it, and somewhere, see here, there's a red here. See here, 20 error has come. Here also there's a red. So if you see the graph carefully, then it's the smallest percentage, that's the reason. So here request by version. So right now I have declared this, I deploy this code actually, this code. So the version 1.0. So that's the reason here you have it. So if you deploy multiple version of source code, let's say today I deployed 1, tomorrow 2, third day 3. So you can see that which is performing well. Day 1, day 2, day 3, and also after that. Here request and errors you can see here, and request per second by version you can see here. This many total request, 1.18 request hits per second at 16:29:00. That's the time. Here request and errors per second. So these are the easily defined. Now if you see that here, this part, so this is like enlarging that graph, and this is basically, if you like this graph, so you can embed in the what is a dashboard or notebook or something like that. And this basically is to declare the incident. So here if you have, see that, declare the incident here, and you can export to dashboard, notebook, export to incident, and also like that. And you can see the view. Here it is, large view. You can see that about the same matrix. So whatever the matrix you are showing, this is the same matrix. You can see that. Now here, this side, you have a latency. Okay, so latency means that typically we present in percentile. So here Apdex score is default. I'll go for the latency by version. latency, historical latency, and it's coming here, and latency distributions. So if you see the latency primarily, this you see in the percentile. See P50, P75, P95, this one. So now the question is, what is percentile? Any idea? Arpan? I think Stephen is not there.
Percentile basically in P95, it means like 95% of the request.
Actually, so when I say P95, that means I want to tell you what is a P95. So P95 means 95% of the people are having request response time, which is, let's say, 6 minutes, 6 seconds, if I say. So that means remaining 5% people have a response time more than 6 seconds. So if I say 99 percentile, which is, let's say, 2 seconds, that means 99% of the people is getting the response time within a 2 second, but remaining 1% people are getting the response time more than 2 seconds. So let me show you one slide which will help you to understand, and that is this one. So look at this. So here, simple table to understand. Okay, so let me take a snapshot of it. So here total, this is the latency in a second, and this is the total number of requests. So what is the total number of requests which we have? Tell me.
The total number of requests would be sum of all the number of requests.
So here total number of requests is 100, correct? So now I will ask you one question. What is a P99? Tell me. What is a P99?
P99. So sum of all the latencies.
No. So P99 means, see, this is the 100 request. Okay. So here it says total 1 second latency for 5 requests. How response time was 2 seconds for 5 people. The response time was 3 seconds for 10 people. Response time was 4 seconds for 40 people. Response time was 5 seconds for 20 people. Response time is 6 seconds for 15 people. Response time was 7 seconds for 4 people. Response time is 8 seconds for 1 person. So that means overall 100 traffic is come 100%, just for the easy understanding. And this is also latency, response time. So if I say P99, that means this one. Okay, and that is 7 seconds. Got it? So if I say P95, that means this one. That means 6 seconds. Are you understanding now?
Yes, yes.
Yeah. So like that. So here, if you see context, put it in this context. So here you have a percentile. So this is the, if you are from CBSE, probably you'll understand the percentile concept. So this is the algorithm. So means total number of requests has come, and if I see P50, by the way, this application is not having much difference actually, because I'm using very less small applications. So all are almost same here because of application was loading in the microseconds. So here you see P99 is 2.01%. P95 is, I'll disable this, 2.01 second. P90H, I'll disable this to same actually. So here you will not see the difference, but actually you'll have a differences and all. So P99 means these are the 99% of the people got the response time which is less than 2 seconds. P95 means 95% of the people got the response below than 2 seconds. Or P90 means 95%, 90% of the people got the response time below 2.0 seconds. So this is the way. So now this information will help you to see that, okay, what are the user experience for your applications, and at least give you some insight about it. What are the percentage of people are getting infected, and what is their response time and all stuff like that. Are you understanding?
Yes, yes.
Okay, so now here you see this Apdex score. What is Apdex score? So I will ask you one question here. So tell me, what is the range of Apdex score? What is the range of Apdex score?
Oh, I have no idea what is Apdex.
Range, no, forget about that, I'll teach you. But what is the range of Apdex? See, minimum is 0, maximum is 1. Correct now?
Mm-hmm.
So minimum is 0, maximum. So that means Apdex score is between 0 to 1. Hardcore this. Apdex score will be always between 0 to 1. Now, what is the Apdex score for mine? So right now it's 0.99. Now here there is a T option also is there. So what is this T? What is this? What is this 1? What is this 0? This we need to understand. Are you comfortable so far?
Yes, yes.
Okay, so now the question is, what is Apdex score? So I'll not complicate. Apdex score is basically user satisfaction. I mean, user means customer satisfaction index. Okay, customer satisfaction index means how much your customer is satisfied. So if it is 1, highly satisfied. If it's 0, you know that. Okay, so if it is 1, highly satisfied. If it is 0, highly dissatisfied. In between 0 to 1, so if it is closer to 1, it's good. If closer to 0, it's not good. So this is a satisfaction index. Now the question is, how do you manipulate this? How this in Apdex score get decided? So for that, we need to understand little bit of formulas. Now the formula is, where is the Apdex score formula? Here it is. Okay. So now let's try to understand this formula. You'll understand the Apdex score. So here, see this end user send a request to, and then it process this response, and you got the response time. So can I calculate this as a response time R? Can I do that?
Yes.
Response time R. So this is what it says. This response is R, represented in R. Now let me ask you one thing. Let's say this application is developed by you, and given a scenario, I will ask you only, right? Okay, this is your application, you developed it. So what about if a 5,000 people will hit to your website every minute? What will be the response time? If 5 lakh people or 10,000, so you will say like that, right? So here this is the T. T means threshold. That means this is set by developer or team. I'll put it at team. So this T means this will be decided what exactly the response time would be. So here let's say response time is in reality 5 seconds. Okay, but here I said, okay, my response time, the threshold which I'm setting up as per my development, I feel it should be 10 seconds. So this is good, no? You said that T 10 second, response time is 5 seconds. But if you say, let's say if you're expecting the response time is 1 second, but if you're getting the response time in reality 5 seconds, correct? So it's the worst condition, correct now? All of you? Hello?
Oh, yes, yes.
Yeah, so this is the R, which is the real one, and this is the T, which you expect the application to perform. Now the question is, okay, so total. So the question is, which user is satisfied, which user is tolerating your application, and which user is frustrated. So for that, if R is less than equal to T, that means those traffic is coming under the satisfied bucket. If R is greater than the T, then those users are coming into the tolerating bucket. And those users who's having the R is greater than 4x of T, so those people are frustrated. Okay, so these are the 3 buckets which been created now from your traffic, total traffic. Now the question was, what is Apdex score? So Apdex score is nothing but a satisfied request plus tolerating request by total number of requests. Okay, that's a formula, and this should come always between the 0 to 1. Let's look at this here. So here if you see if you have a See here, if you have a total satisfied request is 100, and what was the formula? And tolerating request, because you have 100 satisfied requests, so tolerating you become a 0. So what is the Apdex score? 1. So if you have a satisfied request 0 and tolerating also 0, that means everyone is frustrated with the application. So what is your index Apdex value? 0. So 0 means worse, 1 is best, and that is what. So now with that context, see these options. So R will be taken from the APM side, Datadog, and T use basically you can search it up. This is a T, okay, and R will be taken from the real one, and based on that it will calculate whether it's 0 and 1. This is called customer satisfaction index. Understood right now?
Yes.
Okay, so now here you see that here how many total number of errors you got it in 4 hours, and here when you got it, how many errors you got it, what was the kind of error. You can see through this graph. Errors by version you want to see here, errors per second by version you want to see, v1 v, so all this thing. Here errors per second you can see here, errors rate by version, percentage of error rate, so here you can see, and error rate. So right now error rate is in last 4 hours is lesser than 0.1%, so that's okay. Okay, now here you will have a dependency map. Now right now I don't have it, because if really applications will call it web, then here application, then a database, so you'll have a something like this service map. In New Relic we call it service map, here we call it a dependency map. So like that you'll have a having mapping, and when you hover over there, so you'll get to know for that particular service how much requests to per second or latency, error rate, and all stuff like that. Here you see the resources. uh, by resources you have all these are the 3 resources. You can see each resources request and request per second. You can see the deployment, so I did the deployment v1, right? So this is the v1 deployment, and for this my deployment, this is the request, this is the p95 p75, same thing but in a different visualizations. Here same thing for this particular version only. If you see the tracking, here you have, here you have, these are the infrastructure which is involved in it. So that is something which you have it. JVM matrix which we have not enabled, actually, or is enabled, yeah. So here you have Java matrix, all the traces for this particular. Here you again you have it, log patterns, which is the next topic which we'll discuss about it. So now this is the stuff. Now here let's click on the each traces, and here you open up this each traces. Now here you see the span, so let me show you the span. So this is the span, so this is one span. So in real you'll have something like this, 2 3 4, and for this particular trace these are the call has happened, this is the span time you'll have like this in the real time. And this is the flame graph, the one which you are saying. Span list, if you want to see this, click on the span list. So scroll down a little bit, here it is. So if you have a too much of many multiple internal calls, you will see for the each services you'll have a multiple call. Map also you can see that, so this traces is belong to which particular service map, and you can see the request, latency, error, exit time, spans, and all. So the more you spend time with UI, little bit of more meaningful every day you build it actually. So this is important. So filter flame graph is important. And right now, because not too many things are coming, the reason is this application is very small applications, only one class file like that. So here you can see the info which on this particular trace, which run on which infrastructure, what was the matrix of that server, CPU, RAM, and all. Logs I have not enabled it. Processes where this trace has been generated, which process running. Here you can see. You can also enable at the code level also. That means for this particular trace, what was the code got executed. This is not enabled because it consumes lots of CPU and RAM. But yeah, for learning purpose, you can try. This is called code hotspots. Okay, so these are the things you can try. Now go to this stress here. This is a continuous profiler. Continuous profiler we have not enabled, so that's the next topic. One topic we'll have for the continuous profiler also. So any questions so far, guys, you have?
No. Yeah,
Okay.
I have to drop in like 5 minutes. I have to start work.
Yeah. So now here you see each services in real time. What you will have here, you will have hundreds of services. So I have enabled only 2 services, and this is a summary of it. So look at the summary, and here you can understand this. So request, latency, P95 error rate, and also flag. If you want to download this here, download CSV, you can customize this each column using this. So whichever you want to see or don't want to see, you can customize it here. So more or less, this is a dashboard which you got it. You have to understand each and everything here. And for monitoring purpose, so let's say I have detected some problems here. So what is the problem? So here there's a problem here. There's an error. So I can also declare the incident. Okay. And here declare the incident. I see some issues here. Okay, which is a severity 5, 4, and all stuff like that. And give the some instructions here. Graph is all automatically embedded and declare incident. So I created one incident. If you refresh it, one incident you can see here. Now go back to the APM services. 4 hours. Go to this, and here you see that there is one incident open for this particular services. Okay, so now if I see that here, the request hit right now is not running because all services stopped, but you can set the SLOs also for like that. So how do you set SLO? So you can click here, add a new SLO, and you have to specify that criteria for SLO. So request timeout and all stuff like that. So what is the metrics based or monitoring based? So metric based, what is this? So I'll go for like Apache hit a number. See Apache net number request pers, which is from production service Deloitte check. Okay, so like that you can set a target machines. This is SLO, you set it up, and for this what should be the value for it. So 3 machines is there for setting up the target here. And one more thing which you have to do is where is this host so target should be 99, and warning when it is 90%. Okay, it's at 98%. Warning 95% target I'm giving, and warning I'm giving 99 90 93%. Okay, so this is some warning saying warning should be shown target 93 95. So target is my 93 SLO, and whenever it reaches to 95, then I should see that and then save it. So now you go back, I set up one SLO and done. Some you can decide the error budget and all stuff like that. Some here set just notifying Rajesh and Warne is consumed. What is missing? Here there's a problem. Okay, subject was missing. So create. So now this SLO got created. You can go to the services and 4 hours and click on this. So see here for your service, there's no SLA coming. Should come actually. No SLA. Let me check this. Monitor SLOs for my service. So yeah. So this is correct. So query. Yeah. So it's correct for the service. Not sure why it's not coming. So I'll check after some time also. Sometime refresh issues. So this is the way you can create a SLOs for it. So now your job is to understand entire graph for APM and help your projects to see that which is the response time. So what is you are going to do? So primarily if you want to start your work, so see that what is the error and which request which is here is taking more time. So you can filter it by duration. So if you see here, okay, I'm hitting fast actually. Hold on. So here, click on duration. See that you find out the culprit. Why this resources has taken 2 seconds. Maybe your expectation was 1 second or something. So that is something which you can start with and get going. Are you understanding, all of you? All of you? Stephen?